So at a place like a women's hospital where they handle a lot of maternity, they actually have an entire department of genetics and genetic counseling. So if you are pregnant or thinking about becoming pregnant and you have a known family history of a genetic disease, you may well get referred to the genetic counselors. And you may want to go in and sit and talk with them. Are you done? Thank you. What those people do is they take a detailed family history, and in the days before genetic testing, they used that genetic history to try to determine what the chances were that you were a carrier, and if you were a carrier, in fact, what the odds were of your child being impacted by some condition or disease. These days, there is genetic testing for a lot of conditions, not all conditions, but for a lot of conditions, there are commercially available genetic tests. And I mentioned when I was pregnant, I was tested for cystic fibrosis. Turned out I was not a carrier, so we didn't have to go any further. What you have are case histories, Gesundheit, for two couples. You are going to be the genetic counselor. And each of you has a slightly different combination of case studies. There are 4 autosomal recessives and 3 sex-linked, and you all have different, I scramble them up and make copies. So you've got 2 couples basically coming to you looking for advice. This is going to suck up about the next week of our lives together, working on pieces and parts of it. There are a couple new skills that you're going to build in order to complete this activity. And then there are a couple old skills that you're going to apply to it. So the new skills you're going to build, the first one is constructing a pedigree. And a pedigree is just a record of ancestry. It's a way to trace. All a pedigree is a way to trace family relationships, and very often also to trace a condition or a trait through a family, through a group of genetically related individuals. That's the first new skill you're going to build, creating a pedigree. The next thing you have to do is then be able to analyze that pedigree, to be able to look at a pedigree and determine things about the individual's genotypes that are represented. Because you're going to construct a pedigree for the couples who you're working with as a genetic counselor. And this is something that genetic counselors commonly do, is actually construct pedigrees for couples. Once you've got that pedigree and you've started to figure out what the genotypes of everybody in the pedigree are, then you're going to take the old skill that you've already got of doing Punnett squares for crossing single traits, and you're going to figure out percentage possibilities that a given individual could be affected. Okay? So that's some of the old skills that you've got that we're now going to apply to this new thing. So to start with, we're actually going to begin with some notes on doing pedigrees, and we're going to practice the simplest possible pedigrees first, and we're going to gradually make it a little bit more complicated, kind of the way we usually do things. The sheet that you have, the genetic counseling exercise, you're welcome to look it over, but you're probably not going to do a whole lot with it today. You do need to keep it. If you do not feel that you can be trusted to keep it, you can put it underneath. Don't put it in because we've got other stuff coming in today. Put it underneath the return tray for biology. Okay? So, what is a pedigree? Well, like I said, it's a way to trace relationships. And the first simplest thing is that, squares are males, circles are females. That's easy. And because we are tracing conditions and traits through a group of related individuals, we have 2 different kinds of males and females. We have those who are unaffected by whatever this trait is, who don't have it, and we have those who are affected. And affected is shown with a darkened square or circle. We can use this to trace anything. We can trace a disease like cystic fibrosis. We can trace something like red hair or freckles. We can trace crooked pinkies. We can trace wet and dry earwax. We can trace any genetic thing using a pedigree. Okay, well that's an easy place to start, males and females. Now, of course, we don't get related individuals unless people start to reproduce, right? So when 2 individuals partner and reproduce, we put a line connecting them in the middle, like that. That's a mating line. We don't care about legal status. We don't care if they're married or not. What we know is that these 2 people reproduced together. So when 2 people reproduce, they have offspring, and we show their offspring as circles and squares down from the original couple who mated. This couple had 2 daughters. They have 2 girls. Easy enough, right? So far, we're not showing any of them as affected. When we're doing pedigrees, we try to keep our generations together. So let's say this daughter partners, reproduces, has a son. Here, we'll even make him affected just to keep things interesting. We don't know what the condition is. We haven't said that yet. So what we've got now is generation 1, generation 2, and generation 3. We really try very hard to keep those all on a level. Okay? Here's a question for you. This is sort of a sidebar. So what's that person's relationship to this person?
That's their niece or nephew.
Okay. Yes. This is his aunt. This is her nephew. Right. And the cool part about these pedigrees is we can document and chart really complicated family histories. You can chart multiple matings with different partners that produce offspring. So, you know, I always have a kid who says, well, I've got 2 half-brothers on my mom's side, I've got 3 half-brothers on my dad's side, then there's me, and then, yeah, we can chart that. Just takes more paper, that's all. You can chart individuals who are adopted, who are raised by one family, but who have their genetic roots elsewhere. That's especially useful if you're looking at something that may or may not have a genetic component, but has an environmental component. The house that you were raised in might influence whether or not you're affected by the condition. So we can chart all of that. A few other things. This, a line like that through somebody, means they're deceased. We very often don't show that unless it's relevant to the case that we're discussing, like if we think they died of the disorder we're talking about, or if they died especially young, if there's something like that. You know, if we're charting 5 generations, we're pretty positive that great-great-great-grandma and grandpa probably aren't around anymore. We don't necessarily have to document that. Okay, so let's do one let's do one together, let's practice. I have a couple. You can call them Herb and Ethel. You can just call them Generation 1. I don't care what you call them. You don't have to call them anything. You can call them Grandma and Grandpa if you want. How many kids did Herb and Ethel have? Hold up fingers. 5. They got 5 kids. They had 2 daughters, then they had a son. Then what happened? What are those? Twins. Now, these are fraternal twins. Fraternal twins start off with their lines coming directly off that sibling line at the same place. They're 2 siblings who just happen to be born at the same time. Fraternal twins are 2 eggs that are fertilized by different sperm. They are no more related than any 2 other siblings. They shared a womb for 40 weeks, but other than that, they share the same amount of DNA as any 2 other siblings. So this is a male and female set of fraternal twins. Identical twins are always same-sex. Fraternal twins can be same-sex or they can be opposite sex.
Wait, identical can't be 2 different
No, because identical sex. Sex and gender are different. Gender is whether you feel like a boy or a girl. Sex is your plumbing. So identical twins start off as 1 egg, 1 sperm. So identical twins are either both XX or both XY, or again, we said there are some unusual, some less common configurations, triple X, XXY, XO. But identical twins have all the same chromosomes because they start off as a single fertilized egg that then splits incorrectly and ends up yielding 2 people instead of 1. Okay, so that's our first and second generation. Now, she partnered. She had a daughter. Ooh, then, what did she have? Twins, identical twins. And you can tell these are identical twins because their little line comes down off that sibling line as a single egg and then it splits. So they started off as a single fertilized egg and it splits into 2 people. Okay, and we'll leave the second sister unpartnered. We'll give them 1 boy. And we'll give her a couple of kids. She can have a girl and a boy. Now, we haven't made anybody affected yet. That's okay. We'll get there. So, these are identical twins. Okay. If we draw in our generations, oops, switch to red. There's generation 1, generation 2, generation 3. We could easily add a 4th generation, but first let's talk about some of the relationships here. What's the relationship of this person to these two? They're cousins. Yes. So all of these offspring we're showing in the 3rd generation, they're all cousins. They're all first cousins. They share a set of grandparents. Okay. Let's go one more generation here. He had 2 girls. She had a boy and a girl. He had a single daughter. Okay. We can do infinitely large pedigrees. Okay. Tracing out, starting from one couple, we can trace all of their descendants. A really common thing that we need to show is, well, my mom and dad got divorced and then my mom and her new husband had 2 kids, or they had a kid. How do we show that? So let's focus on this guy. So we see that he partnered with her. They had 2 daughters. Well, let's say that partnership ended and he remarried or repartnered again. We don't care about legal status here. We're only interested in the fact that they reproduced together. We don't care if they were legally married or not. We would draw a new partnership line over here, and let's say he had a boy this time with his new partner. So this individual and these 2 girls are half siblings. They share one parent. And my lines on him and his ex-wife and his current wife are a little messy, but very often we'll change the solid line to a dashed line when that partnership's no longer active and there's a new partnership. You don't have to. It doesn't matter. In a pedigree, again, we don't care about the order of who was first, who was second, who's current, who's not current. We don't care. We don't care about legal status. We don't care about any of that. All we care about here is biological reproduction. Okay? So, other common scenarios. We'll cover some of the other ones like adoption and non-genetically related individuals a little later.
Yeah, I was going to ask about that.
Yeah, and it's an easy one to show. The compelling reason that we usually would show, well, here, let's go ahead and do one while we're thinking about it. So let's say he partners. They adopt 3 girls who are biological siblings. There are their 3 adopted children. We're showing that they are being raised by this couple. They are environmentally in this family. If we know anything about their biological parents, we can show them over, oops, I'm doing that wrong. We can show them like that. And that we usually set it off to the side, sometimes put in parentheses, and that says they're not being raised by these people. They are biologically related to these people. There are cases where people don't have a whole lot of information about their genetic relatives, and they may have other kinds of information. So that covers a lot of the cases that pop up. Okay. Level of confidence with creating a pedigree, 0 to 5. Okay, you get started drawing it. I've started you off with your couple. 3 sons, 1 daughter. Son number 1 has 2 girls. Son number 2 has a boy, then identical twin girls. Son number 3 has 1 girl, and the daughter, the youngest child, has 4 boys. So you should have started off with something like that for your second generation. And then those boys get mates, and the daughter gets a mate. In the last class asked, does it matter which side the male or the female goes on? It doesn't matter. Does it matter the order that you go in? Generally, we try to keep it in birth order, so the oldest, then the next one, then the next one, then the next one. But if we're looking at two families that are coming together and we need to show the spouses who get married on the outsides of their family, that's fine. We can adjust and modify. So all the kids got a spouse. Son number 1, 2 girls. Who's got that? Good. Son number 2, 1 boy. Then, whoops, I did that wrong. Then identical twin girls, little cherry stem there. Son number 3 has an only child, 1 single girl. And then daughter number 4, I didn't leave a whole lot of room here. There are her 4 boys. The big thing, you will get better at spacing. You'll get better at kind of visualizing what you're going to need to leave in the way of space. Make sure you keep your generations level. That's a big deal.
I forgot to add spouses and stuff.
Oh, so they like spontaneously reproduced all by themselves? Not biologically possible, but I've seen it before. Without a partner, you cannot have offspring. May or may not know the partner. You know, you referenced sperm donor. Yeah. And then you would, I don't know how you would show that exactly. I mean, you would show that biological connection to the offspring. No, you wouldn't show it straight down because that shows. No, they have a biological partner. Every offspring is the result of sexual reproduction, which is the result of a male and a female gamete. So there's a biological partner. Now let's look at some affected individuals. Okay, so we're going to trace wet earwax in this family. Ew. At least it's after lunch. We did this before lunch for the other class. Okay, so Grandma and Grandpa. Who has wet earwax? Grandpa's got wet earwax. Grandma has dry earwax. Of their offspring, how many of their offspring have wet earwax? Be careful. Be careful. Oh, son of a gun. That's an in-law. 50%. Their oldest son and their youngest daughter. That other affected individual in the second generation is their daughter-in-law. She is not a biological relative. We only care about her earwax from the perspective of her kids. All right. In the last generation, there any families where there are no affected individuals? Yeah, first family, third family. Okay, so here's a question. Do you think this trait is dominant or recessive?
Yeah, recessive.
I hear dominant, I hear recessive. Well, if this was in fact a recessive trait, so if the affected individuals then, if wet earwax was little e and dry earwax was big E, then is there any, can we tell either grandma or grandpa's genotype? So grandma has dry earwax. We're saying dry is the dominant. So if grandpa was in fact recessive, what would his genotype be? Little e, little e. If it's recessive, he would have to have 2 copies of the recessive allele in order to be affected. So if it's a recessive condition, we know that if he's affected, he's got to be little e, little e. Well, that would mean that, do we know grandma's genotype? Okay, we don't know her genotype. What we know is that she could be big E, or she could be big E, little e. Okay. If that's the case, would we expect to see what percentage of, well, if they were both homozygous. Homozygous. He recessive, she dominant. Every single one of their kids would be what? They would all have to be big E, little e. If, in fact, they were this and this, every single kid would be big E, little e, big E, little e, big E, little e. Is it possible that they're both homozygous? Is it? Are big E, little e's affected?
No.
No. Do they have any affected offspring? Yeah, they do. They have 2 affected offspring. So, she can't be homozygous dominant. So we know that that's not the case because at least some of their offspring are affected. So if some of their offspring are affected, then what do those affected offspring have to have as their genotype? If this is a recessive trait, then they have to have 2 recessive alleles to be affected. So all those affected individuals would have to be little e, little e. So if that was the case, we know that grandma would have to have, she would have to be a carrier. Okay. Do we know the genotype for this individual or this individual? Yes. They're not affected, so we know that they're not little e, little e. But look at Grandpa. What did he give them? A little e. We know that they are something little e, and since they're not affected, what must they have gotten from their mother?
Big E.
Big E. So we know that they have to be carriers. Can we really tell if this is dominant or recessive? We can't. We can't actually tell in this case. And actually, I drew this pedigree intending to make this a dominant trait. But I wanted to see how it would run if it was recessive. Looking at this pedigree, it's possible that it's recessive. But let's do one and call it dominant. We'll code for another trait. Copy. Boom, boom. Paste. Let's do the same exact affected, affected, affected. Oops. Affected. And then who did we have back here? Twins are affected and the 2 boys in the last family. Okay, so same thing. Let's go ahead and say that this is a dominant trait. So, earwax, wet is big E. And dry is little e. Now, can we tell either grandma or grandpa's genotype? Whose genotype can we tell, Matt? So, if you have wet earwax, what are your possible genotypes?
Big E.
You could be a big E, or you could be a big E, little e. If you have dry earwax, we know right off the bat what your genotype is. Little e, because you've got 2 recessives. So, can we tell grandma or grandpa's genotype? We can tell grandma's for sure. She's not affected, and these are the affected individuals.
So she's little E.
We know for a fact that grandma has to be little e, little e. Yes?
And grandpa has to be big E.
Well, why do you say that?
Because if you look, kids are
Aha. Exactly. Because we know, well, yeah. We know that this one is not affected, this one is not affected. So what's their genotype? Guaranteed.
Big U. I mean,
Littly, just like your grandma. Littly, littly.
Oh, I was looking at.
They had to get that other little e from someplace. So grandpa can't be homozygous. It's not possible. Okay, this is the analyzing pedigrees part. So I'm going to pass out a worksheet that's all about building pedigrees on the front part, and I want you to do the front. You can get started in the 5 minutes or so we've got. The back side is analyzing pedigrees. And so I want you to finish the building a pedigree before you try to analyze.